A vector is a quantity represented by an arrow that has both direction and magnitude, as opposed to a scalar. A scalar is just a number. It doesn't have any direction. You can think of a vector as a move in a certain direction by a certain distance. For example, this right arrow represents a move to the right by 1 unit. And this arrow represents a move to the right by 2 units. They have the same direction, but different magnitude. Two parallel vectors with the same magnitude are equal, because they represent the same move. It doesn't matter where they start. These two vectors are parallel and have the same magnitude. They are equal, although they start from different places, because they represent the same move. There are two kinds of vectors, displacement vectors and position vectors. Displacement vectors start from any point. For example, this vector starts from A and ends at B. It is written as AB with an arrow on the top. Vectors can be put in a coordinate system. Position vectors start from the origin. For example, this vector starts from O and ends at A. It is written as OA with an arrow on the top, or little a. Here A is in bold. In handwriting, it's hard to write it in bold. So we use little a, with an underbar to denote a position vector. All vectors have an equivalent position vector, because we can always move them to the origin. To add two vectors, we can use triangle rule. Connect two vectors head to tail, and the sum is the vector starting from the tail of the first vector, to the head of the second vector. For example, vector AB, plus vector BC, is equal to vector AC. The two vectors AB and BC are connected head to tail. This can be interpreted as, move from A to B, and then from B to C. So the final result is, move from A to C. For multiple vectors, connect them all head to tail. For example, vector AB, plus BC, plus CD, plus DE, is vector AE. When adding two vectors, we can also use the parallelogram rule. Connect two vectors' tails together, and the sum is the diagonal of the parallelogram with these two vectors as two adjacent sides. For example, vector AB and vector AD are connected by tails. To find out their sum, we make a parallelogram with these two vectors as two adjacent sides. And the sum is the diagonal AC. We can see that it's easier to use triangle rule than parallelogram rule to add vectors, especially when adding multiple vectors. From the triangle rule, we know, AB plus BC is AC. So, BC is AC minus AB. We can see that AC and AB share the same tails, A. Therefore, when you subtract two vectors, you connect their tails together. Like this. And AC minus AB is BC. Similarly, BC is OC minus OB. Since position vectors can be denoted by little letters, BC is C minus B. And MN is N minus M. We can put vectors in the coordinate system, and write them in terms of two basic unit vectors, I and j. I is a vector along the x-axis with magnitude 1. J is a vector along the y-axis with magnitude 1. All vectors can be expressed in terms of I and j. For example, point A's coordinates are 2, 3. Then vector OA is 2i plus 3j. From the origin O, you go along the x-axis by 2 units, and then along the y-axis by 3 units, you'll reach A. Point B's coordinates are -2, -3. Then vector OB is -2i minus 3j. From the origin O, you go along the negative x-axis by 2 units, and then along the negative y-axis by 3 units, you'll reach B. This vector format is called the Cartesian format. It is written as xi plus yj. We can also write it in column vector. That is to put x and y in the vertical form within round brackets. Notice you don't put I and j in this format. For example, vector OA is 2, 3, and vector OB is -2, -3. With these notations, when we add or subtract vectors, we need to add or subtract corresponding components. For example, AB is OB minus OA. So it is -2i minus 3j minus 2i minus 3j, which is -4i minus 6j. We can also write them in column vectors. It becomes -2, -3, -2, 3, which is -4, -6. It's recommended that you use column vectors, because it's less error prone. If vector OA is xi plus yj, then its magnitude is written as modulus OA, and from Pythagoras, we know it is the root of x squared plus y squared. For example, if OA is -4i plus 3j, then OA's magnitude is the root of -4 squared plus 3 squared, which is 5. A unit vector is a vector with magnitude 1. There's a unit vector on every direction. We already know the magnitude of vector OA is 5. So if we divide every component of OA by its magnitude 5, we get the unit vector on the direction of OA. It is -4 over 5i plus 3 over 5j. You can verify its magnitude is 1. To get the unit vector on the direction of a vector, we divide it by its magnitude. If AB and CD are parallel, then AB and CD are multiples of each other. And vice versa. For example, given 4 points, A1 3, B-2 1, C6 7, and D12 D, and AB is parallel to CD. Find D. AB is OB minus OA, which is -3 -2. CD is OD minus OC, which is 60 -7. Since AB is parallel to CD, they should be multiples of each other. By dividing the two x components, we know -2 times AB is equal to CD. Therefore, D minus 7 is 4. So D is 11. M is the midpoint of A and B. What is vector OM? AM is half AB. AM is OM minus OA, and AB is OB minus OA. So OM minus OA is half OB minus OA, which is half OB minus half OA. Therefore, OM is half OA plus OB. For example, OA is 1, 3, OB is 3, 5, so OM is half OA plus OB, which is 2, 4. We can see that it is the same as the midpoint formula. Given 4 points. A -2, -1. B3, 0. C1, -2. D -4, -3. Find if ABCD is a parallelogram. We know we can add two vectors with the parallelogram rule. So if the 4 points form a parallelogram, AB plus AD must equal AC. Let's go ahead and see if this is true. AB is OB minus OA, which is 3 0 minus -2 minus 1, which is 5 1. AD is OD minus OA, which is -4 minus 3 minus -2 minus 1, which is -2 minus 2. AC is OC minus OA, which is 1 minus 2 minus -2 minus 1, which is 3 minus 1. AB plus AD is 5 1 plus minus 2, which is 3 minus 1. It is equal to AC. Therefore, ABCD is a parallelogram. If AB plus AD is not equal to AC, then it's not a parallelogram. In this class, we learned: there are displacement vectors and position vectors. Displacement vectors can start anywhere. Position vectors start from the origin. Vectors can be added with the triangle or parallelogram rule. AB is OB minus OA. A vector can be written in Cartesian form, xi plus yj, or column form, xy. When adding or subtracting vectors, we add or subtract corresponding components. The magnitude of vector xi plus yj is the root of x squared plus y squared. If AB and CD are parallel, then AB and CD are multiples of each other. And vice versa. If M is the midpoint of AB, then OM is half OA plus OB. If ABCD is a parallelogram, then AB plus AD is AC. And vice versa.